Assalamualaikum, selamat sejahtera. Physics Form 4, Lights and Optics, Subtopic 6.2, Total Internal Refraction. My name is Cikgu Suryati Yusof. I am from Sekolah Menengah Sains Muzaffar Shah. Our topic for today is 6.2, Total Internal Refraction. The learning standard is the first one, describe critical angle and total internal reflection. Second, relate critical angle with refractive index n equals to 1/sin c. 3. Communicate to explain natural phenomena and application of total internal reflection in daily life. 4. Solve problem involving total internal reflection. So diamonds are famous for their sparkle. A diamond glitters when it is moved about. Why does a diamond show such brilliance? A turtle is below the surface of water. A reflected image of the turtle can be seen on the boundary of water and air. Why does this happen? These phenomena are due to the characteristic of light, total internal reflection. Let's begin with activity 1 to explain total internal reflection of light. Diagram below shows a light ray is directed from air towards a semicircle glass block and move out to air. Okay. What happens to the light when it enters from a denser medium to a less dense medium? So the incident ray, from a denser medium to less than medium, so it will refract away from normal lines. Okay. Compare the intensity of the refracted ray and the reflected ray inside the glass. So there is also a refracted ray, but it's a very weak internally. So refracted ray is brighter. Relate incident angle and refracted angle. So this is the incident angle, this is the refracted angle. So directly proportional. As I increase, R also will increase. Okay. So we can prove from this diagram. Okay. So this is the semicircle glass block. This is the normal line. So the greater the incident angle, the greater the refracted angle. So we start with this one. So it will refract away from normal line. Next, the incident angle increase. So the refracted angle also will coming towards the glass boundary. Okay. Okay. At one point, the refracted angle will be on the boundary of the glass air boundary. Right. So angle of refraction approach to 90 degree. So this is angle of refraction, R equals to 90 degree. So at this moment, this is the special name for the incident angle. This is named critical angle. Okay, we continue. Diagram below shows that the angle of incident increase, the angle of refraction also increases. So what happened to the light ray when the angle of refraction reach 90 degrees? So refract on the glass air boundary. So this one, okay, it refract on the glass air boundary. This is the limit of the light ray that can be refracted in air, right? The angle of incident in the denser medium at this limit is called critical angle. So this is the incident angle, which produce refracted angle of 90 degree. So this incident angle is known as the critical angle. So critical angle, the symbol you see is the incident angle I, where refracted angle R equals to 90 degree. So actually critical angle is an incident angle when it produce R, refracted angle equals to 90 degree. So what is critical angle? Again, critical angle is the incident angle I where refracted angle R equals to 90 degree. So this is the incident angle ray. So this is a normal line. So this is the incident angle equals to C when refracted ray produce refracted angle R equals to 90 degree. Now what happened? Diagram below shows situation where angle of incident I exceed critical angle. So we increase the incident angle larger than C. So that just now the maximum is on the boundary, but this time what happened? It will reflect in the glass. So there will be reflection inside the glass. So the light phenomena is called total internal reflection because the reflection occur in the medium, the glass, and all the lights are already reflected. No more light outside. So all light are totally reflected inside the glass block. State the two conditions so that this phenomena can occur. First, light must travel from denser medium to less than medium. So light must travel from denser to less than medium, from glass to air. Secondly, angle of incidence larger than angle of critical angle. That is, I must larger than C. Okay, now we do an experiment to obtain critical angle and observe the total internal reflection. So this is the procedure. So we have a white paper. We put the semicircle glass block on the paper, and we trace first the semicircle glass block, and then we draw the normal line. Okay, next we put back the glass block, and then we use the ray box to shine an incident ray straight to the point here, okay, to the normal line, and then we will see the result. Okay, so remember, this is the normal line, this is incident ray, so this is what we call incident angle, and this is the reflected ray. And also we want to observe the reflected ray inside the glass block, or what we call total internal reflection. Okay, so this is the observed experiment, total internal reflection. Okay, put the glass block. This light ray, so we move straight line, straight, parallel to normal line. Okay. Okay. So we increase the incident angle. So this is the refracted angle. Okay, so approaching the glass block boundary. Okay. Okay, approaching the boundary. So R increases as I increases. So this is the refracted angle, but it's a dimmer, right? Okay, towards the end, it will touch here at the boundary just now. So now it's exceed the critical angle. So in order to find the critical angle, what we have to do is go back. So I think this is the moment for the critical angle. Alright, that is the critical angle. So I is equals to C, so R equals to 90 degree. Now we move further. So when we move further, so it will become total internal reflection. Okay. Okay, so result is that if the angle of reflection are less than 90 degree, what happens to the refracted ray? So it refracts away from normal line. We measure the incident angle I when the refracted angle is 90 degrees. So when we do the experiment, I equals to 40 degree. Complete the following diagram based from your observation in 1, 2 and 3. Okay, so we have 3 observation. I less than C, I equals to C, I larger than C. Now we plot the observation. So when I less than C, it will refract away from normal line. When I equals to C, it will be on the glass boundary, glass air boundary. And when I larger than C, all the light will be total internal reflection. Okay, so the critical angle is 42 degrees. So refracted away from normal line, I equals to C. Refracted ray is at the boundary of glass air. And when I larger than C, total internal reflection occur. Okay. So explain why the light ray must be directed at the center of the glass block from the curved edge. So we use this part for the incident ray to pass through, because light parallel with normal line. So for every angle you go, it will always be parallel to the normal line, because this is the tangent line, this is the normal line, always perpendicular. Therefore, light parallel with normal line. Okay. What is the critical angle of the glass block? Okay, we have 42 degree. So again, I less than C, refract away from normal line. I equals to C, refract along boundary glass air. I larger than C, total internal reflection occur. Okay, I hope you can remember the phenomena for three situations of I. Okay, now we move further. We want to find the relationship between critical angle C and the refractive index. So look at this diagram. So the light travel from liquid Y, which is denser, to air. So this is the critical angle. So this is the incident ray, refracted ray equals refracted angle, equals to 90 degree. Okay, first we use the formula. So we need to find the relationship. Okay, so what we do is light travel from denser to less than medium. Therefore, N equals to sin R over sin I. Remember, sin R, the above one is bigger than the incident angle. So we know that R is 90 degrees. So I equals to C, R equals to 90 degree. So N equals to sin 90 divided by sin C. And we know that sin 90 is equals to 1. Therefore, N equal 1 over sin C. So this is the formula that relate N, index of refractive index, and critical angle. Okay, so N and C is inversely proportional. So N is index of refraction, C is the critical angle. Okay. Alright, so we have an exercise. The refractive index of water is 1.33. What is the critical angle of the water? So we use the formula N equals to 1 over sin C, and 1.33 equals to 1 over sin C. So sin C equals to 1 over 1 of 0.33, and we use the inverse sin, is we get 48.75 degree. Okay, next question. Diagram shows 3 light ray X, Y, Z. So we have X, Y, Z. Incident at the midpoint of AB. Okay, semicircular glass block. Okay, critical angle is given 42 degree. So we have three line here. N O Z. Where is N? Okay, N O Z equals to 30. N O Y equals to 42 degree. N O X equals to 60 degree. Now draw the direction of the rays of X, Y, and Z from O and label them as Y, Z. X, Y, Z respectively. Okay, now we start with 30 degrees, right? So 30 degrees is less than 42, so it will refract away from normal line like this. Y, okay, the incident angle is 42 degree, and compared with the critical angle, they are equal, so it's on the boundary. Okay, next, the angle now is 60 degree. So 60 degree is larger than critical angle, so total internal reflection occur, and the refracted ray angle equals to 60 degree. Okay, right? Okay, that's the question. I predict what happened. So now N equals 1 over sin C. Sin C equals 1 over N, 1 over 1. So we get the critical angle equals to 50 degrees. Sorry. Now the angle of incidence is given 55 degrees. So 55 is larger than 50. I larger than C. Total internal reflection occurs. So this is the ray diagram. The ray will be total internal reflection. Again, we have what we call glass prism of 45 degree. So determine the critical angle of the glass. Again, we use the formula N equals 1 over sin C. So sin C equals to 1 over 1.51, and C equals to 42 degree. Again and again, we use the same critical angle. Draw the ray light after it passes through a point P. So this line will be what we call parallel with the normal line, so it will go straight here. Okay, then you have to draw the normal line. Okay, now where is the location of I? So here is the location of I. It is 45 degree because 45, 45, 45 degree because this is 90 degree. Yes. Now this is I, so I 45 degree. C is given just now 42 degrees, so I larger than C, so it will be total internal reflection. Okay, another question. Draw what is the critical angle of the glass. Okay, so this is the boundary. On the boundary, so R equals to 90, so this is normal line, so this is incident, so this will be the incident angle equals to 50. How we get 50? This is 50, this is 40, so total it should be 50 plus 40, so that's why this is 50 degree. A light ray incident on the plastic block X will show the critical angle of plastic. Okay, so critical angle must be from denser to less dense. So not here. Okay, from here to here, yeah, this is denser, this is less dense, so this coming, this normal line, so C will be the critical angle. Okay, now we have a very interesting activity to observe the phenomena of total internal reflection in a water stream. So these are the apparatus, a Coke, a bottle of Coke, 1.5 liter plastic bottle, plastic basin here, laser pointer, wooden block, retort stand, water and sulfate. Okay, so what you do is you put water inside the bottle. Okay, and then you open the cellophane tape, then the water will flow like this parallel curve, right, like this, and then you shine up the laser pointer. What you observe? Okay, so this is the observation. So this is the laser pointer. So this is the green light, which shows that the laser pointer pass through the water, even though the water is curved. So this is the laser pointer, like the laser light. So means that the light travel. So this is the light ray here. The light, the water flow in the curved shape like this, and it means that the laser pointer, the light of the laser, follow through the water here, right? So this is what we call total internal reflection. Okay, so this is the picture. So this is the laser pointer, laser cascade. Okay, again the zero from what inside water, outside, then so to less than, so go straight away from normal line, right? And towards the end, it will become total internal reflection. So this is again another example of total internal reflection. This is the turtle just now, turtle. So this is the total internal reflection due to the total internal reflection. So this is the image form. Okay, now we move on to the last part, explain natural phenomena and application of total internal reflection. So we have two natural phenomena and 3 to 4 applications. So we start with mirage. Okay, on hot days, a distant road will appear to have pools of water lying on the surface on the surface of the road. So when reach at the place, the pool of water disappear and actually it does not exist. How this phenomena is called mirage. How this phenomena occur, right? So in hot days, a person traveling in a car will see an imaginary pool of water appearing on the surface of the hot road. Okay, the layers of air near the ground are hotter than and less dense. So this part on is hotter. So when we move outward, it will become denser. So now our object is the layer higher up are cooler and denser. Light ray from the sky, so this is our object, the skies, right? Light rays from the sky travel from denser to less than medium, and it will refract away from normal line. Okay. Angle of incidence increase and it reach an angle greater than critical angle at this point. Okay. So total internal reflection occur. So the light is reflected towards the eye of the observer. So the eye interpret lights come from the road, not from the sky. So this is the the light that is total internal reflection goes to the eyes of the observer, but the observer see that the lights coming from here, not from the sky. Therefore, the eyes interpret lights come from the road, not from the sky. So this is the image seen on the road, and it seems like water because the sky is always moved, right? So the observer see the image of the sky as pool of water appearing on the road surface. Alright. Okay, hot day compare the temperature of air at higher level and air near the road surface. So the air at higher level is cooler, near the road is hotter. So compare the density of hot air. So cool air is denser. What happens to the light ray from the sky which travel from denser to less dense air? So it will refract away from normal line. Incident angle will increase. Compare incident angle with the critical angle. So incident angle larger than critical angle. So total internal reflection will occur. So again, when incident angle larger than critical angle, total internal reflection occurs. The light is reflected towards the eye of the observer. The eye interprets light comes from the road, not from the sky. Okay, so this is how we got the image of water on the surface of the road. Okay, so the observer will see the image of the sky as a pool of water. Okay, this is the more picture of mirage. So it seems like there is water here, right? It's water, but this is only the imagination in the mirage. Okay, now we move on to rainbow. So this is a colorful of rainbow. So a rainbow is a colorful natural phenomenon. When sunlight shines on millions of water droplets in the air after rain, we see a multicolored rainbow. So this is one droplet of water. Okay. Name the phenomenon, which is the separation of light into colors arranged according to their frequency. So this is light white color. So when it enter the drop of water, it will separate into 7 colors. So this is what we call dispersion of light. Okay. Dispersion means the white color is separated into 7 colors of spectrum. Now, so state the 3 light phenomena which produce rainbow. Okay, first it will disperse, then refraction because it travel from air to the water, and there will be total internal reflection. What happens when white light enters the raindrops? So refracted and dispersed into 7 colors component inside the raindrops. Okay. And what happens when the invisible light hit the back of the raindrop? So this is dispersed. So at this point, it will become total internal reflection. Okay, total internal reflection, and refracted again, and it will leave the drop as 7 colors. Okay. So the color of rainbow run from violet along the lower parts and the spectrum to red along the upper parts. Okay. Now we move on to the prism periscope. Name component to build a prism periscope. 45-degree glass prism. So the glass prism here, the blue color. So what is the incident angle? Incident angle here is 45 degree. Critical angle for glass prism is 42 degree. Compare I larger than C, so it will become total internal reflection. Okay, total internal reflection. Okay, draw. Okay, you got like this. This one, you got that. Okay, this is that's why you got the image is upright. Okay, state the characteristic of the image form. So virtual, upright, same size. Okay, same size, upright and virtual. Explain to advantage. First, the image is brighter because all the light energy is reflected. The image is clearer because there are no multiple images formed in the mirror periscope. Also, the image of seen through the periscope is upright. Okay. This one. So this is by using the prism. All light are total reflected, but this one not all the light reflect. Part of the light are going to inside the mirror. Inside the mirror. Okay, this for the plane mirror. Okay. Binocular. So this is the use of binocular. Set the use of binocular to see distant object. What happens to a light ray enter the binocular? So mana dia? So as it enter, it will be total internal reflection. twice in one prism, twice a total internal reflection occur. So characteristic, white, virtual, upright and same size. So very important. Now draw. Okay, we start with this one. 45 degree. Okay, move there. Okay, again on at the bottom. So it is same size and also upright image. Okay, binocular. Okay, again binocular. Okay, binocular. The benefit of using prism in binocular, so an upright image is produced. The distance between objective lens and eyepiece is reduced. This makes the binocular shorter as compared to a telescope which has the same magnifying glass. Okay, so binocular is a shorter telescope actually. Okay, fiber optics. What are the uses of fiber optics? Communication, medicine. They the material for fiber optics, glass or plastic. Compare the density of inner core Q. So this is a Q, inner core, outer cladding layer P. The density, so this must be denser. So Q denser than P. Compare the reflecting index. So the denser the material, the higher the reflecting index. So it will be Q larger than P. Okay, complete the wave path. Okay, like this. That's why it's a very fast way to send the signal from one point to another one. So explain why the light ray experience total internal refraction when it hits the inner wall of the optical fiber, because incident angle is larger than critical angle. Very easy answer. Okay, give advantage of fiber optics. They are much thinner and lighter. A large number of signals can be sent at one time. Very little loss in energy over great distance. The signals are safe and free of electrical interference. And they can carry data for computer and TV programs. Okay, so these are few advantages of the fiber optics. Okay, this is the image of the fiber optics. So this is what we call endoscope. Okay, endoscope in the medicine to see help the doctors. There's a camera to see the inner part of a patient body. Okay, endoscope. Oh, we have a glittering or sparkling of diamond. A diamond has a high refractive index. It's the densest material in the earth. A diamond, so have high refractive index. Remember the formula N equals to 1 over sin C. So they are inversely proportional. The higher the refractive index, the smaller the critical angle. A small critical angle means total internal refraction already occurs. It can occur readily, very easy, because the critical angle is small. Light is easily reflected inside the diamond. In this way, more light will be confined atau terperangkap within the diamond before reflecting out into the air. Okay, that's why it sparkles, because there is light inside the diamond because of total internal reflection. Okay, now we have a few calculation to make. So C is 24 degree for diamond and glass is 42 degree. So low critical angle give total internal reflection easier. High critical angle reflected away from normal. Okay, so we have a calculation here. So calculate the critical angle of diamond and glass. So we have just now we show you by using the formula. So C equals to 41.8 on the, we round up to 42 degree. Diamond is C 24.4 degree. So we have with the same incident angle, what happens? So this is 30 degree. Diamond, glass is 42, right? So I less than C, so it will so I 30, C 41.8, so it will total internal reflect away from normal line. Okay, like this. So now move on to diamond. I is 30 degrees, so C is 24.4 degree. Now I larger than C, so it will be total internal reflection. So like this. So we have another one. So many internal reflection can occur in diamond. Okay, thank you. Thanks for listening for my lesson tonight. So see you next time. Hope you understand. Bye. Assalamualaikum.